By 2030, digital infrastructure is expected to support applications like high-fidelity holographic telepresence and the tactile internet, the ability to transmit physical touch or haptic feedback across thousands of miles to operate machinery in real time. These applications are currently hitting a wall. 5G architecture relies on hierarchical transport structures, meaning data hops through multiple physical network layers to reach its destination. For a standard download, that delay is negligible, but for remote surgery or industrial automation, the lag is a total physical roadblock. This chart shows the available sub-6 GHz spectrum used by modern mobile networks, and it illustrates a massive resource problem. We are nearly out of space. As millions of new devices come online, this limited spectrum creates an invisible traffic jam, capping how much data can move at once. Achieving the technical demands of 2030 requires abandoning the bigger pipe approach in favor of a new architectural foundation. Global telecom authorities call this standard IMT 2030. We know it as 6G. The first major leap involves moving into untouched frequencies. 6G systems will operate in these sub-terahertz and terahertz spectrums, specifically the range between 100 GHz and 1 terahertz, to harness new physical properties of wireless transmission. On the left is 5G's maximum data rate of 20 gigabits per second. On the right, 6G harnesses terahertz frequencies to hit 1 terabit per second, a capacity 50 times higher. Zooming in, latency drops to 100 microseconds, enabling machines to react instantly. Capacity is only the raw material. The real shift in 6G is how the network will process this massive influx of information. This architecture introduces native sensing, also known as integrated sensing and communication. 6G radio waves do more than just carry data. They actively map the physical world, acting as a pervasive radar system. As radio signals bounce off objects, the network independently estimates range, calculates velocity, and maps the environment, creating millimeter-accurate 3D wireframes of the surrounding space. These are mandated engineering requirements. Official 6G service documents explicitly list native sensing as a core capability, alongside requirements for native AI and AI in network. That requirement for native AI introduces the AI plane. Instead of adding artificial intelligence to an existing system, 6G is built with AI from the ground up, allowing the network to organize, optimize, and heal its own connections. To execute this, the architecture is being flattened. By merging cloud infrastructure, edge computing, and terminal devices into a single layer, 6G removes the data travel bottlenecks that cause current network lag. This structure turns the network into an intelligent entity that understands the physical space it occupies. Combining ubiquitous intelligence with native sensing enables the cyber-physical world. Every physical object, from a single tool to an entire city, can be mirrored as a digital twin, keeping physical activities and digital data in constant synchronization. This synchronization expands coverage from a 2D terrestrial map to a global 3D network. By integrating satellites and deep edge nodes, 6G extends its reach to the skies, the oceans, and remote regions. 6G acts as the invisible bridge, keeping digital and physical realities in lockstep across any environment. Realizing this requires overcoming severe physical roadblocks. Terahertz waves offer high bandwidth, but they have short propagation ranges and struggle to penetrate solid obstacles. Harnessing them demands entirely new antenna designs and semiconductor packaging. There are also digital hurdles. A network governed by autonomous AI requires new cybersecurity protocols and trust mechanisms to secure sensitive data as it is processed at the edge. The official 3GPP and ITU timeline shows the path forward. Following the vision definitions in 2023, 6G technical specifications are expected to be locked in by 2028, with the first commercial systems scheduled for deployment in 2030. By 2030, 6G is scheduled to transition from a technical specification to the invisible, sensing infrastructure that underpins global communication.